What's up there, CW fans? We are in for another installment of putting together the CFT1, and we are almost there. I think we have, let's see, if we go to the documentation, I think we are like on page or step 20 something. So if we go down to, we installed the trimmer pots, we installed the little LED, we installed the encoder, and now it's time for the electrical check. So step 25, electrical check. We've got to do a couple of double checks just to make sure there's no shorts or anything weird. We're going to get our voltometer out and double check those things. But before we do that, I had mentioned, when we're doing all this soldering, you can kind of see that there's, a lot of solder flux that's still on some of the circuit boards. And while this is not a huge deal, particularly for circuits like this, I kind of like to clean it off, and I usually use something like heavy-duty flux remover. And sometimes, if it's really hard to get off, I'll just kind of squirt it in there. I like to keep this away from like LCD panels or any other plastics or anything like that, because I have had it eat away at like a display plastic on me. So, but this is safe for electronics. Obviously, it's kind of meant for this, but I kind of do one of those deals and let that evaporate. It evaporates pretty quickly, but that's the one side, and then the other side looks pretty brutal. Look at all that goop all over the place. So what I'll do is just kind of hit that lonely guy up there. Then I'll just do that. I like to take an old toothbrush that, particularly when I travel, I'll go to hotels and they have extra toothbrushes you can ask them for, and they're kind of really perfect for situations like this. Just kind of like wipe that off. And then do a little quick once over. And just let it dry up a little bit. That's one board. As it's evaporating and drying up, you'll see it's a lot better than it was. You might have a little bit of residue on there that you can just kind of like wipe off. Piece of cake, no big deal. But makes the board just a little bit more presentable when you do it like that. There's other stuff. You can really get this stuff off nicely with some other stuff that I've used called Blue Shower, which is pretty good stuff. But I figured, just to make it a little bit more presentable, I'll just do this and get the solder flux off. Just do that once over. It does seem kind of weird that we're like dousing these chips with flux remover, but it should be no problem. We'll soon find out when we boot it up, right? Got a little bit of goopy in there. I like to use a toothbrush because just doing the straight squirt doesn't always do it. There we go. So we're just going to let that evaporate. And you can kind of see that this is already evaporated. It looks pretty good. Looks pretty nice without the solder flux all over the place. There's some on the front of this. I didn't take the protective cover off of this yet because I knew I was going to do this. And I don't like the splatter even coming off of this going on to like the LCD or any of the plastic parts. Although it does say it's safe. I don't necessarily believe it, even though I just got it all over these little push buttons, which are plastic. I have had it once where I was doing this with it had a liquid crystal display on it, but it had a plastic cover on it, and for whatever reason it kind of fogged up that plastic cover. So ever since then I've been super careful with this solder flux remover. But like I said, they do have, yeah, you can even kind of see that. I don't know if you can see that. Kind of like fogged up a little bit of these guys here. Maybe it's just solder flux that's on there. Oh yeah, maybe it is. Looks like it's solder flux. Just kind of like got splashed onto there. But yeah, just be careful if there's like plastics, because I don't trust this stuff, even though it says it's okay. All right, so we're gonna let these dry up. I'll take this plastic piece off of the LCD. Get this out of here. And let's start looking at what the next steps are. So for the rest of these steps, we're on page 45, and I think there's 10 pages left. I wound up grabbing a speaker because we need to plug a speaker into this to be able to hear stuff. I also grabbed a Morse code key. We're going to need that to key up this radio, as well as my ICOM 705 with a dummy load on it, because we're going to need to key up this radio to do some fine tuning. So what's left now is putting the radio together. We're going to calibrate it and do some testing. So that's kind of where we're at. So now looks like this is pretty dried up. Got a little bit of flux on there. I'm not super worried about it. We're just going to kind of let that go. Yeah, these are the two pieces of the puzzle here. This next step, step 25, before we apply power, it says we need to check a few things to make sure that there aren't any issues with the board. So what I did is I did carefully inspect the board to make sure that there weren't any solder bridges or anything like funky like that. Everything looked like it was legit. Even put it under the microscope just to make sure. It says inspect transformer L16 in particular for solder bridges. That would be this person right here. And because there are two leads that come off of each side, it seems like it's kind of common for those to bridge over, but I think we are good. So what I'm going to do is I'm going to turn on my multimeter, which you can't see it, it's over here. And we're going to do some testing here. So we're going to look at the RF board, which that would be this one. And we're going to look at so you can kind of see that there's the BNC connector, 12 volt, 6 volt, and then there's ground. Same thing here. And then what we're going to do is make sure that we have from 12 to ground, we have some resistance. Same thing with 6 volt to ground resistance, then 12 volt, 6 volt, some resistance. So let's make sure that that is the case. So I've got, let's see, let's put that on resistance. And we're going to do this one first. And then from this, here, let's zoom this in a little bit for everybody. So from 12 volt to ground, so that would be 12 volts here to ground. We're looking at, let's see here. There's 12 volts, there's ground. We're looking at actually 19, which is higher than their resistance, but I think that's okay. Let's do 6 volt to ground. All right, so that's showing 5. Let's just do that again. Okay, so that's showing 2. I don't know what I was doing there. There we go. So that's 2.5. That's showing 5. That's showing 2.5 mega ohms. So they're both showing 2.5 mega ohms. So that fits right in the range there. And then from 12 volt to 6 volt, the same. Let's go from 12 volt to 6 volt. Oops. And looks like we've got about, come on everybody. Something's weird with my meter here. All right, let it reset. And it looks like we've got about 10 mega ohms. That's what what we should have. All right, cool. Our control board, which is this one, we should have from 12 to ground. So let's see here. They've got it flipped over like in the diagram here, right? Right there. So we've got 12 volts, 6 volts. So what we'll do is do something similar. So 12 volts to ground. It's showing 5.7. 12 volts to ground. Let's see. It's supposed to be kilo. Oh, yeah, 5.7 kilo ohms, which looks like that's right. So 6 volts to ground. I'm showing 3.6, which is right. And then the last one, 12 volts to 6 volts, like this. I'm showing 6.8, which is a little bit right in the range there. So our initial check looks good. So that means we passed step 25. Now we put the boards together. So step 26, we're going to use this 3D printed perimeter pieces. So that would be these three. And it goes together like an ice cream sandwich, right? So take 4 of the M3x6 male to female hex standoffs. So we've got, so the male to females, right? 1, 2, 3, 4. And put them into the center 3D printed perimeter, the one with the 3 notches. So we've got notch 1, 2, and 3, right? And it looks like it wants it oriented this way, right? So with the notches down. Don't want the 3 notches down. All right, cool. So what we're gonna do is, looks like they want us to just drop them in like so. 1, 2, 3, and 4. Whoops. It says next, push the center print into the control PCB. You might have to press a little bit to get it to fit in place, but be careful, otherwise you might break the 3D print. So what we want to do, it looks like they want us to take the control PCB, which is this, and gosh, is that the way it's supposed to go? No, it's not. Is that because it's supposed to go this way? Yeah, I think it's supposed to go this way. So we'll keep those in there. Whoop, one just fell out. That wrong way. Let's see, let's throw that in there like so. There we go. So I think we also take 4 of these. We throw this control board on like so, right? Yeah, I'll just take these stupid things out. So throw this on like so. Looks like it fits pretty decently, right? It's gonna go on like an ice cream sandwich. And then, so we'll throw that in there. We'll throw that in there. And then I believe we do this. Like so. Throw that in there like that. Put that in there. Screw them together. So basically what we're doing here is we're putting this in that little receptacle and we're screwing this in like that. And I'm just doing finger tight. There we go. Cool. So I think that's what it's supposed to look like. That's what it looks like. All right. Looking all right. All right, so that's step 26. All right, now next take the front 3D perimeter with no notches and press it into place. Let's see here. It says there are two small cutouts that align with the two pads of the jack. Is that it? Looks like those are the two little baby cutouts, possibly. They're not even really cutouts, it doesn't even matter. So that goes on like so. So that's the very first one. Yeah, so there's a couple of little, yeah, I guess there's some little cutouts that are required right over there. All right, so that works. So we've got that. Then take your RF board and press it into place. So this is our RF board. Looks like we need to flip it over. We've got these headers that are going to bind to each other, right? Is that kind of like what it's looking like it's going to be? Like so. And then we need to make sure that those headers stick into each other. Trying to do this gently. Making sure all of these pins are straight. Let's make sure there's nothing here. That looks good. It's aligned. Man, that's going to take a minute to figure that one out. Gosh. Just kind of like looking right in there. I know you can't really see it, but it looks like everything's lined up. Bingo! So it just needed to pop in. All right, that was a little nerve-wracking, but we got it. So that's what that looks like. The connectors are a tight fit, so keep that in mind. Secure it with 4 female-to-female hex standoffs. So all we have left are these 4 here. So just kind of screw these in. 1, 2, 3. Come on. And 4. Cool, so that's that. And it says take the bottom perimeter 3D print and press it into place. The one with the 2 slots. Actually, that's all that's left, right? It's got to go this way. There's the larger holes that will accept going into these standoffs. Let's see here. All right, this is coming together all of a sudden. Okay, so that takes care of that. So it looks like the sandwich has been put together. It doesn't look like we put the faceplate or the back plate on yet because we need to do some calibration. And it looks like that's what we're going to do here with initial power up and LCD contrast. So this is where showtime happens. So I've got a power supply off camera here. I'm turning it on. And I have it set to 12.7 volts. I'm going to actually move it to 13.8 volts because that's typical power supply voltage. And there's going to be some notes in here about that in a minute. It says for this you need a 12 volt power supply, apply power through the barrel connector, and flip the power switch into the on position. So the LCD will come on during boot up. It'll briefly turn off, then back on. You should also hear a relay click. Once this happens, use a small Phillips head screwdriver to adjust the contrast, turning RV4, which is right here. You'll need to turn it clockwise to do so. Let's see if that all works. So let's plug this in. Oh, and it was already switched on. I heard some relays click. And let's get a screwdriver. And it says clockwise, right? Oh yeah, check that out. It works, it's alive. 13.5 volts. That's exciting. So we've got that figured out. That's step 27. Once you set the proper contrast, disconnect the power from the CFT1. All right. Well, that's kind of anticlimactic. I don't know. That was actually pretty cool. Actually, it turns on and we're rocking and rolling. So, okay, all right, now we get to install the front plate. Let's do that. We're going to put this right on like so. Looks like it just kind of lays on there. Drop it into place. Use the washer and nut to secure the rotary encoder in place. I must have... Oh, how about I take the nut off of the rotary encoder and the washer, and let's drop this in like so. Put the nut on, the washer on there and the nut, and this is going to secure it in place. There we go. Sweet. I think that was it, right? So yeah, that was, let's see here, use a washer and nut to secure the rotary encoder in place. That was that. Remove the M3 screw temporarily holding the IRF 510. So that's that, right? So they want us to take the screw out, huh? Remove the screw. All right, cool. That takes care of that. And it also says, remove the nut and washer from the VFO encoder if you haven't already. Oh, yeah, that's what we did because I think we had to do that up here, right? Fasten the panel to the assembly with 4 M3-6 screws. The washer nut from the encoder. Do not over tighten. All right, it looks like they are the silver ones. So what we can do is flip this over. Put the silver ones in place. 1, 2, 3, and 4. And it says do not over tighten. As a matter of fact, I only just tightened that rotary encoder nut with my fingers. Figure particularly right now it's good enough. We can come around and do some additional tightening later, but gosh, I mean, I think this is going to be, I'm going to treat this pretty nicely. It's not going to be like kicking around all over the place, so I'm not super worried about it. All right, so we've got that, and that looks like the picture. Looks like we're getting close. Finally, take the 2 knobs and press them into the encoder, blah, blah, blah. The one with the white strip is for the volume. All right, so volume. Let's see here. Looks like that was it. And then this one, push it on there. There we go. Perfect. All right, that's step 28. All right, so we have step 29, 30, 31, and 32. That's all we have. So we're going to start, the next step is going to be the 10 megahertz calibration. And we'll get that cooking right now. So to perform the calibration, we need a frequency counter, which I have one here, or another receiver, which I also have one here too. What we'll do is it's preferable to have a receiver with a spectrum display, which I do. And so we'll see where the frequency is. This will be shown on the ICOM. This I do have a 705. You can do an RTL SDR. All right, cool. So apply power through the barrel connector and turn the radio on. Now we need to enter a calibration menu after that too. So let's plug this back in. There we go. And it's back on. So what we need to do is enter the calibration menu and select the 10 megahertz. So how do we do this? Pressing the menu? No. Oh, menu. There we go. Panel direction. calibration menu. I think there we go. All right, select the 10 megahertz ref adjustment. Let's see, Short press to edit this item. You should see the 100 hertz on the display. Place the antenna of your receiver. Here we go. Should probably get into the 10 megahertz section of this then. So let's go here, 10 megs. I'm gonna maybe go into CW mode. And let's bring it up to 10 megahertz. Okay, there we go. Now what we also might need to do is attach a piece of wire to the center conductor here. There we go. All right, so press the knob, enter the short press the out, you should see 10 hertz. Place the antenna of your receiver near the bottom right of the CFT for best reception. Okay. Now let's see here. That works. In the above image, you can see the frequency signal is low. I'm not seeing any frequency signal on here, as a matter of fact. I wonder if this dummy load is not helping out matters. Getting it really close. No, nothing. Might have to figure this out. Maybe I can do the span here. Nope. It's not looking quite right. Might have a little bit of an issue here. All right, I'm going to see if I have everything hooked up right and make sure that I reread this. And let's see what we can do. Let's see if we can figure this out. All right, so what I thought about doing, I was hesitant of doing this, but apparently it's such a low signal. I'm taking the antenna center conductor and going from center conductor to center conductor. Looks like it's barely even. I don't know if you can see that. Yeah, let's move this over. So it looks like I have the span of this pretty close. And what you're supposed to do is start moving this so that that line comes closer into right there. And then what you can do is you can press that. I think you press and hold maybe. Let's see, I think he says, once you get this as close as possible, press the VFO knob to confirm. Cool. Then long press the VFO knob again. It goes to 1 hertz increments. I don't think I can zoom in enough on this to get it that perfect. Let's see, I'm already on the 2.5K, so I think that's probably right on the money. And if I have my CW pitch at 750, I'm in CW, it's like negligible difference. So I'm just going to keep it right there. And I think that's going to be good. Let's see here. You can zero beat the frequency. I mean, for what we're doing, this is going to be pretty dang close. Once we're done, it's recommended you power cycle the radio after exiting the calibration menu. So yeah, we'll just do that and then power cycle the radio. All right, so that takes care of the 10 megahertz calibration. The next one is calibrating the IF frequency. You want to make sure that you can hear a tone. So this can be done by injecting a tone into the radio, or by using another QRP radio, this one, transmitting into a dummy load, which we certainly can. Here's the dummy load. Get that plugged into there. So let's see here. The nano VNA has an option, which is great, blah, 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 la-di-da. You should now hear a tone through your headphones. So I think we want to, maybe I skipped over it. Calibrate, we need to nano VNA. Finally, you can use a WWV, use an attenuator. You should now hear the headphones. So yeah, I think we need to go to something like 20 meters maybe. Plug this in. Yeah, let's just stay at 14045. We'll go like this. And then what I'll do is plug in some audio here, which I'm not hearing anything. Not sure why. No. Oh, but yeah, I don't know if you just saw that. If I hook up my CW paddle to the paddle, you'll see we're pretty much right on frequency, which is pretty cool. Now the fact that I can't hear anything is a little bit of a challenge, but it might be this speaker, which I just dropped it today, so I might need to try another speaker. So let me go get another speaker and we'll be right back. Okay, we're back and I got it figured out. I've got this pulled out just a little bit. It is a mono plug, and I don't know if this is a stereo. It might actually be. So I just pulled it out a little bit and you can hear. So this, I have this all the way down and I'm keying this radio and I'm hearing it through the speaker on here. So it's actually working. So that works out pretty good. Let's see here. So what we need to do is tune this. We should hear tone, which is great. Enable RIT by long pressing the VFO knob. So there's RIT. And adjust the value up and down to see if you can get an increase in volume. So that's lower. That's about, yeah, it's probably about right there maybe. So 0.03, which it just so happens to be minus 0.03. Let's see if it, I mean, I don't really tell a difference. Yeah, maybe. Coincidentally, it's also 0.03 plus on mine, as well as in the instructions here. You should raise the IF value by 30 hertz. So disable RIT by long pressing. Okay, I just did. Go to the calibration menu. Let's see, calibration menu's right there. Tap that once, and then we need to go to the IF frequency, right? There it is. Let's see here. Calibration menu. As you do, you should hear the audio getting louder. So I guess this is it. It's getting less. I'd say right about there. So I'm going to accept that value by pressing the VFO knob. And that's that. Now the last thing to do is to calibrate the power amplifier. So this is incredibly important. So you have to read all this stuff. He wants you to read everything because we could screw this whole thing up. All right, let's turn this off. Put that aside. And let's see here. There are 2 trimmer potentiometers on the RF board. So let's flip this over. And there they are, 1 and 2, right? RV1 and RV2. RV1 sets the power level, and RV2 sets the power, amp drive level. So make sure you're using a 12-volt power supply for this procedure. We're using 13.8, which is fine. So we're going to adjust RV1 accordingly. So actually, you know what? I'm going to bring this power supply down to 12 volts exactly, just so I've got some pretty good accuracy. This power supply is pretty accurate. There we go. 12.0. All right, good deal. First, turn both RV1 and RV2 fully clockwise. So clockwise means to the right, essentially. Okay, there's 1 and there's 2. So they are totally clockwise. Next, connect a paddle and either put the radio in straight mono or straight stereo, depending on what key you have. Hook your radio to an RF power meter and dummy load. So we need a power meter and a dummy load. I'm going to need to go get the power meter. So we'll be back in 1 second. All right, I've got my power meter. I'm going to take, let's see, the output is going to be, let's get this out of here. Got a BNC connector here to PL259, SO239. So I'm going to put the dummy load on the output of my power meter. And then I'm going to connect a little adapter here so I can then plug it into here. I don't know where I'm going to put this. Maybe right there for now. Running out of space. But let's put this into paddle direction is normal. Straight stereo. Let's see, let's plug this in also. All right, cool. So I'm going to flip this around like so. And it says, okay, so we've got it fully clockwise. Connect the paddle. We got it in there. We're in straight stereo, which is what we have. Hook the radio up to an RF power meter, which we've got, and a dummy load. Make sure the band is 20 meters. We are in. All right, go to the calibration menu and change the PAOSC setting from enable to disable. Oops. So calibration menu. Oops. Calibration menu. So we want to make this disable. Okay, so we've got that done. So it's on disable. Take your multimeter and clip the positive lead to the gate of the IRF 510, the one connected to the rectangular pad, and clip the negative lead to ground. The leads on top of the 4 crystals can be used for this. That's a really good idea. Ensure you're not shorting with the positive. So looks like we need to have our lead connected to that bottom lead there, right? Yeah, let's see here, the one connected to the rectangular pad. So if you can kind of see in there, there is that bottom lead is connected to the rectangular pad. So what we have to do here is, let's get some clips. I'm going to clip this because they said that's a really good idea for the ground here. So that's like so. And what are we going to need? So we're going to be looking at volts. So let me change this to DC volts on my meter. So let's see here. I don't know if I have a clip small enough. So what I'll do, I might have to do this just manually like this. So it's not registering any volts right now. That's good. So next, press down the paddle to turn on the power amplifier. You want to adjust RV2 such that you read 2.5 volts. Okay. I'm going to go like this. And I'm going to adjust RV2, which is the one on the right. So this one right here. So yeah, this is it's going to be interesting. Let's see if I can get a little baby clip on there, just barely. That should do it. Okay, so we've got that. And I don't think we're supposed to key up that much. So there's 1 volt, it's 1.3, and they want 2.5. All right, so we got 2.5 volts on that. Let's see here. Enable that, make multimeter, blah, blah, blah. Press down. Once you do, disconnect the multimeter for the radio and change it back to enable. All right, so we did that. Let's yank that off of there. That was dangerous. All right, let's go back to enable. Okay, so we got that. Now press the paddle down and adjust RV1 so that you see 5 watts coming out of the radio. You want to do it only 5-second bursts because we don't have the heatsink connected to this, so that makes sense. So right now, it looks like 2.5 volts. And I guess, how can I set this up for you guys to see this? Maybe that works? I mean, I could see it. So let's see here. There is 5 volts. I'm gonna leave it right there. Good? Perfect. All right, so I think we've got that taken care of. If we're using a 13.8 volt power supply, we can set it between 5.5 to 6 watts. That's why I wound up reducing it to 12 watts on my power supply, so I don't have to worry about that. And then the last part is closing up the transceiver. So we're going to take the thermal pad and place it on top of the IRF 510. So kind of like so, right? Actually, we can disconnect all this stuff now. Get back to normalcy here. All right, so let's get the thermal pad. Pop it in there. Take the cover and place it on top and fasten. Wow, that's about as easy as it gets. That's kind of cool. I think it goes that way. Yes, it does go that way. cool. So, looks like we only have 5 screws left, so that one has to go in there. And then these guys have to go in here. And then all that's left to do is put the rubber feet on, and we're calling it complete. Let's screw these babies on. So it got a little messy here with the SWR power meter, number 1. Number 2, I wish I could put my volt ohm meter on the screen. It's actually a desktop unit. It's over there. Let's get this screwed in there. But it's kind of mounted, so I can't really move it around. And I got my camera mounted right now too. All right, so that's it, right? Almost kind of an anticlimactic end to everything. So next thing we're gonna do, we're gonna activate some POTA with this thing. So I'll see you on the bands, and CW on, my friends. All right, I can't leave you without powering this up one more time. There we go. Beautiful. Looks good. Click, click. And yeah, we can actually hear some stuff out of the speaker. Very awesome. Yeah, if you want to see more about this this unit, I also have a couple of videos. Yeah, I like this to be like right up 720. You can see some other videos. I actually activated a park on the air using this thing, so it's a beauty. All right, now CW on, my friends.